Maybe you have been constantly applying for AI roles like AI engineer, GenAI developer, ML engineer, but you're still not sure about the difference between terms like AI agent, agentic AI, Gen AI, and traditional AI. It's okay, you're not alone. In fact, many professionals in the field still struggle with this confusion, especially when it comes to understanding what each role requires. And if you don't have a clear grasp on these differences, it can be hard to know how to tailor your applications or even decide which role is the right fit for you. So, without this understanding, you might find it difficult to choose the right path, let alone ace the interviews. And that's exactly what we are diving into today. In this video, we will break down these key concepts and show you how modern agentic AI systems are changing the game. These systems can reason, plan, use tools, and take real actions, like checking order statuses, triggering refunds, or even completing payments. And these are the exact skills that companies are looking for in roles like AI engineer, GenAI developer, and ML engineer. And if you're ready to master these skills and stand out in your job applications, make sure to join our AIML job program and start building real-world agentic AI projects that employers are actively seeking. And to know more about it, join our free masterclass on AIML and Agentic AI. The link is there right in the description and pinned comments. This free class is your chance to get a proven roadmap and framework that helps people like Shrija, Steve, and Debashish land their dream AI roles. So now let's get into the video.
Fine. So, what is an AI agent? Okay. Now, until now, loosely, many of you might have been using these words AI agent and agentic AI a bit interchangeably, loosely. Okay. There is a difference, although nuanced. Okay. That should be clear by the end of today's session, that it would be one of the key takeaways. Okay. Henceforth, we will not be using these two terms at least interchangeably. Okay, we'll be more cognizant when to use which term. So agent is like agent in Matrix movie. Have you seen Matrix movie? Is there anyone who has never seen a Matrix movie? Any of these parts? Agent, black coat, white shirt, black tie, agent. So if you type agent, maybe on Google, most likely you will see that agent only. Let's see some of the agent images. That is interesting. Okay. Agent term came a bit later. I mean, see, I'll tell you the problem and the irony of this industry. Okay. I was working with neural networks even in 2009, 10, 11. Okay. And then one fine day around 2016 or 2017, I was also doing some trainings. Okay. And that time I was doing trainings primarily on machine learning and doing neural networks for some research-based applications. And I was not doing active training on that. And somewhere around close to 2016 and 17 started. Okay. I got a call from some vendor saying, Prashant, can you do training on deep learning? I thought, okay, deep learning, what is this? Then I studied back and realized after a couple of days, this is all neural networks. So I've been doing neural networks for more than 7, 8 years. And one fine day, someone called those neural networks deep learning. So same thing here. So the word agent had been there. It's just we got a new look and feel for that agent term. Okay. So now when I refer to the word agent, you should look the word agent as like a person, persona. Okay. So AI agent is a person, like an intelligent person who is being powered by LLMs. Okay. That's the reason I'm bringing this analogy here. Okay. So AI agent is like a specific employee hired for a job. Let's say John is the accountant and this guy is an agent. Okay. Now, since John is the accountant agent, okay, there could be another HR agent, there could be a coding agent, and so on. So these are like specific people who are specialized in specific tasks. They know their job well and they will have some set of tools at their disposal which they will use in their job. So this guy called as John, who is an agent, let's say, he has some tools like calculator, some software like Tally and accounting software you can think of. Okay. But primarily, let's say definitely a calculator on his desk at any point of time. Okay, because he is an accountant. Okay, and this guy would receive inputs which are I mean, typically invoices, reports, and something, or maybe even um, receipts. And this guy will do all the data entry in that accounting software, and at the end, prepare some financial statements. Fine. So this is clearly a person. I have defined a persona. What is the job this guy is supposed to do? Okay, the JD is clear. This is what you are going to get. This is what you will process, and this is the expected output from you. But then what is agentic AI? How do I correlate with that? Okay, so agentic AI is like the job description of this agent. If I want to hire an agent, or if I want to create an agent, okay, what all skill sets will I need? What all tools and technology this agent is supposed to be having access to? What all capabilities this agent must have? So that description, that framework is your agentic AI in a way. So agentic AI refers to the quality or the characteristic of a system that enables it to behave like an agent. Okay, so it's the underlying architecture or the framework, and will have a lot of these capabilities like autonomy. Autonomy means being able to perform some task without being explicitly asked for at that point of time. Okay, do reasoning. Reasoning is largely coming from your LLMs. Tool use, this is also what we are going to explore today. So these agents will have some tools at their disposal, and these could be well-defined tools, or you can also create your own tools. So that is also we will learn today. We'll try to create some of the tools, okay, and we'll make them accessible to our agent, okay, and that will give this AI system agentic power. So there is already a agent AI system like RAG. RAG is a AI system ultimately. We created this RAG, okay, in the last couple of weeks. And that was pretty much able to retrieve documents, answer user queries based on some enterprise data, and give well-formatted answers. And we enhanced it by using contextual RAG. We explored different retrievers, chunking strategies, splitting strategies, different document retrievers, and everything, right? But that still lacks agentic power because the entire logic flow is still unidirectional, and it's all hard coded. So if you see, there were two chains we created, okay, back to back, and there was a complete chain which we're calling those two chains. Remember that contextual RAG example that, okay. So we coded two chains back to back, QA chain and so on. And then there was a final full chain, what we call. So everything was very systematically defined that the user query will enter this chain's output will go to the next chain, whose output will go to the final chain, which will do the parsing, and finally the user will get that parsed output. So that was still the data, and the logic flow is unidirectional. Everything is hard coded. Okay, so that doesn't have as of now any agentic power to go back to the LLM and ask for specific refinements, or to go back to the LLM and go for more, nuanced answers, or still if there is no clarity, or it can go back to the parser and say that, hey, the output is still not as per the user requirements, can you redo the parsing, some of the elements are missing, and so on. So that agentic power is still not there, reasoning, action, and planning. Okay, so that is where we want to get into the agentic system. So theoretically, definition wise, that's a architectural paradigm ultimately. Just like a traditional AI, we have a GenAI. So GenAI is not a project. GenAI is not a model. Gen is not a, you know, uh, you can say a tool. Okay. It's more about the framework. It's more about the system. Okay. So similarly, AI, agentic AI is also that paradigm or a system. Okay. So when we are defining an agent, agent is basically the persona of your system, what it is supposed to do with a clear, well-defined task. Okay. And the agent also knows what are the tools I have at my disposal or I have in my arsenal so that I can use the tool as and when needed. Okay. And clear instructions are given to the agent that you are an agent who is an expert in doing this thing. You will get this kind of an input. This is what you have to do, and this is the kind of output I'm expecting from you. So all these are hard coded when you create an agent. Agent cannot create on its own. Agent cannot define himself or itself on their own. Okay. So you have to define the persona, you have to define the expertise, you have to define the tools which the agent can access. Okay. And describe those tools very clearly. If there are multiple tools, the list and description of all those tools has to be explicitly provided to the agent. So how do we do all these things? And that is where the agentic AI comes into picture, where you are creating not only the agents, but the entire system. Okay. So agent could be one part within that system ultimately. Okay. So that system is what we are referring as the agentic AI. Fine. So where we are creating a task, multi-step plan and executing that plan using variety of tools, and we are achieving a complex goal. So focus is more on the behavior and capabilities in this case within the agentic AI, and who behaves or who has those capabilities. That is the agent here. So agent is, so this is, you can say, the environment, and agent is a part of that environment. Okay. So agentic AI is like a JD skill of a accountant. It describes the ability to perform financial analysis, uses accounting software and make decisions based on the financial data. So John is your agent because he possesses these agentic qualities, right? So same thing, I have just tabulated it. Okay. So in a sentence, if you want to use the word AI agent, then say we deployed a new AI agent to monitor our network for any threats, attacks, DDoS attacks, this and that. So that is what the agent is supposed to do. Fine. We built our new monitoring system using an agentic AI framework to enable autonomous problem solving. Yeah. So that entire execution orchestration is being done by a agentic AI framework in which your AI agent is one small part. There are many other parts before and after that agent. Okay. So key takeaway here, you build an agent by implementing an agentic AI architecture, and AI agent is the final product maybe, but agentic AI is that philosophy or the design pattern. So we'll talk about the different design patterns in the subsequent sessions. Okay, now coming to our main things, like what is traditional AI now? So traditional AI has largely been your machine learning and deep learning stuff, rule-based systems, plus classical machine learning, plus deep learning stuff. Okay. And they are primarily having an objective of doing analytical and predictive analytics and modeling and behavior. Okay. So it will learn from the historical data, and they are good in predicting something. Okay. So like classification, regression, predicting the segments, clusters. Okay. For deep learning, again, image classification, speech classification. Okay. And so on. Okay. So they analyze the historical data and predict some of the future data points from specific domain. Fine. So sentiment analysis is also classification and so. So generative AI is where we start doing something different, and that is basically generating new original content. Okay. So in deep learning, we were also able to generate content, but that content was mimicking the input. So for example, a noisy image given to a deep learning model is becoming a clean image. So that is not generating a new content. This just generating a variation of the input. That is what we used to do in traditional deep learning, like variational autoencoder, generative adversarial network, GANs, and so on. Okay. So the traditional GAN models and the variational autoencoder models, they were also having generative capabilities, but we never called them as a generative AI because the kind of content that they are generating is exactly similar to the input data. A small variation of that. That's it. But here, completely new original content we were able to generate, either text or image or audio, video, this kind of thing, that mimics some of the patterns in the initial data. And that is what we call as the generative AI ultimately. And how does it do? By using these LLMs, diffusion models, vision transformers, and so on. So these are the things which are powering your generative AI in a way. So agentic AI is the new architecture that uses GenAI model now. Okay, what you typically call as a large language model for reasoning. So purpose is not just to analyze or create, but also to take an action. That is the most important, enhancement from GenAI. Okay, so it is able to take an action and also achieve some of the complex goals. So that is a delegated execution. So main thing is the delegated execution. Okay. Some real world example to demystify these terms a bit better, you can say. So let's see how each of these AI would tackle the same business problem. I'm taking the same business problem, let's say managing customer support. Okay. So the business is getting high volume of the customer support tickets, let's say for a e-commerce company. So if you want to solve that problem using a traditional AI approach, prediction classification, how would you do that? Okay, so goal is to automatically categorize these support tickets and predict which ones are more urgent. So standard classification problem. Okay, so you need to create a classical ML model, maybe naive Bayes, SVM, decision tree, random forest, XGBoost, whatever algorithms you want to use. But this is a clear case of a text classification. So you already have thousands or maybe millions of support tickets in the last 4 or 5 years. And that would have already been resolved, most of it. The only information that we need from those resolution is which was the department which actually handled the resolution. Was it a billing query? Was it related to, let's say, technical? I'm just giving out some words here. So it could be query related to billing, query related to recharge, or in this case, let's say returns, which is going to go to the logistics department or technical department where some functionality was not as it was advertised in the product. So that is a technical query maybe, or the functionality of the product is not up to the mark. So again, goes back to the technical department who will validate whether it is really so as claimed by the user. So yeah, these are the, and it could be again, uh, you know, uh, another maybe in terms of uh, payments. Okay, that department maybe, so payment declined or payment reversal didn't reflect or maybe doubly charged. A number of reasons could be there. Okay, so which department actually intervened to resolve that query at the end, right? So that is exactly the classification model I can say. Okay, in this case, is it a shipping issue or a return issue? So maybe a data scientist can sit down and delegate with the business and categorize all these support tickets, 5 classes, 10 classes, depends. So that business understanding the data scientist needs to have, okay, and the queries or rather the support tickets were clearly classified. So this label is, let's say my order is hasn't arrived, it's been a week, so that's a shipping issue. Maybe another support ticket saying, how do I return? So that's a return query. So these are the tags you can say, or these are the labels. You create a classification model and that is solved. If you want, you can do a more intelligent, nuanced system. So instead of creating a standard ML model, you can also create a deep learning based classifier. Now, BERT is a deep learning model, a transformer based model, you can say, but ultimately it's still a classifier. You are not generating anything. Okay, so you can fine tune a BERT model. BERT is a transformer model. So bidirectional embeddings from embedding representations from transformers. Okay, that is bidirectional embedding representations from transformers. That is your BERT full form. So ultimately, it's a BERT model. Okay, which uses the encoder network, and you fine tune that for a classification task. So you're not using it as a generative task, you are still using it as a classification task. So that still goes back to your traditional AI, but powered by a deep learning model now. Okay. So more advanced model can understand the nuances, sarcasms, and those things, and also the sentiment very clearly because it has been trained on a huge amount of data and bi-direction, not just in one direction, but the reverse direction of a text was also passed. So it knows pretty well. So for example, in this case, urgency prediction, it would analyze the support tickets and assign an urgency score also from 0 to 5, 1 to 5. So my package is missing and it was a birthday gift for today. That would get a high urgency score. And we already got the return classification, return query classified. So that would, you know, assign it to the right department with the right urgency. So you can mix and match. I'm not saying this cannot be done by this. Even this can be done by this. So it all depends how you want to solve that problem. I'm just talking about the approach here. Okay. So you can use these machine learning or deep learning models, even transformer models as a classifier. That's the main crux here. We're just categorizing the support tickets and predicting which is most urgent. So ultimately, it's two-step classification. First classification is categorization. Second classification is the prediction of the urgency score. So you can take it as a regression problem also if you want. But the problem with regression is it will give you continuous variables. But that is what exactly you don't want. So this is the ordinal variable. Okay, fine. So then the outcome here. Okay, the system doesn't solve the ticket as yet. Okay, it only classifies and prioritizes, placing the correct queue for a human intelligent agent to handle. So some person would actually go and resolve that. Okay. So powerful, but you can say still a sorting system. So generative AI, how does that resolve some of the issues in this case? So now you can create an end-to-end chatbot, okay, which will provide an instant conversational answer to common customer questions. Okay. So the key point here is it is just answering to the queries of the uh, customers or maybe taking the support tickets on that call. Okay, it's still not resolving it. That's the point. It's still not resolving it. It's only so earlier the support tickets were received via emails or maybe some chats, okay, which were non-conversational, okay. But now we have a conversational chat system which will correspond to the customer in a more natural language, okay, and try to understand the problem. And once the problem is understood, it will finally give a summary and give it to the human for the end resolution. That is what mostly still happens in most of the apps even today. The first interaction is with a bot. You give your initial query to the bot. Bot will try to understand what this customer is facing issue. And the moment it is understood that, okay, it cannot resolve it anyway, it cannot resolve it, but it will ask a specific human agent to intervene now. Okay. But by that time, the clear context is set. The summary of the conversation is already there for the human agent. So human agent doesn't have to really ask the entire set of questions once again. Okay, he has clear 4 5 points as a takeaway from that entire conversation we took. So that saved the human agent's time. He knows what exact problem this guy is facing. Okay, and the right human agent has been called for. So whether from billing, whether from logistics, whether from depending on their own authorities and capabilities, right? So that is what we are trying to do here. So model is trained on different documents, manuals, policies, and it's a customer facing chatbot. So how many days? So let's say the customer is asking how many days do I have to return this? And it will automatically, you can say a RAG chatbot, completely a RAG chatbot, which has, yeah, this is your RAG chatbot ultimately. So it knows that for this particular product or this particular product category, the usual return time is 30 days from the date of delivery. Okay. So that is the response, and you have to ensure that it is in the original condition with all the tags attached, whatever. So here the outcome is this system creates a response, tries to resolve the customer query with a human intervention at the end, only if the answer exists in the knowledge base. So this is the very critical point. So it will try to resolve, like here the resolution was the customer is not asking to create a support ticket. The customer is only asking how many days I have to return. And the query was resolved because that answer existed in the knowledge base. Okay. It can't check the status of a specific order yet because it can only check these many documents. It doesn't have access to the live database of the orders and the status of all these customers. Okay. So these are static documents more or less, and the chatbot knows about these things and it can answer. So it can't check the status in real time, or it cannot even process the refund. So since it doesn't have access to real time system, it cannot even process a refund. Okay, because it doesn't have tools to take the action. This is the important part. Why is it lacking these things? Because it doesn't have the tool to access the database. So tool call to a database, which we will do in one of our projects, okay, later. So we'll have a tool call or function call. So function call and tool call, these are interchangeably used. So it doesn't have the tool to access the database, tool to resolve the query, or tool to put the customer query in urgency or in queue. Okay. So it can only say that I cannot access the personal order details at the end. So after this, another line would be just appended. So let me ask my colleague so and so to assist you further. So that means it's clear that this was an agent until now I was talking to, and this colleague name whatsoever is a real human who is going to intervene and actually execute whatever the customer is trying to, you know, ask. So what happens in the case of a agentic case? A real execution happens. Okay. What we also call as the query fulfillment. Okay. Earlier, the query fulfillment was happening. So let me, before jumping into this, let me give another example. Okay. So when I used to teach how to create chatbots, so Google had this, even it has today, frameworks. There are frameworks like Rasa is one open source framework, very, very popular. Rasa framework you can explore. Okay. Um, Azure has their own framework. But one of my favorite frameworks for creating agents used to be from Google, which we call as Dialogflow. Dialogflow, Dialogflow. Okay. So So you can create and deploy it on GCP platform. Fine. So this agent, you don't have to, understand the details of this. This is not even an agent. Okay. So what we used to do then is, so I used to take an example of a pizza ordering bot, which I'll just discuss quickly. So think about a pizza ordering bot. It's like McD is there or Domino's is there, and they have deployed this pizza ordering bot. Okay. So you go to their app, start chatting. Okay, I want to order a pizza which doesn't have onions, but I like olives and pepperoni. So give me some suggestions. Fantastic. Now the chatbot has access to all the pizza items in the menu. Okay. And also their ingredients very well. Okay. So now the chatbot has taken a query in a natural language, and it has been able to extract the intent and the entities. Intent is the guy is looking for suggestions on the pizza items which contain and not contain some of these ingredients. These names of the ingredients which the user mentioned is called as entities. So if you go to Dialogflow, you will have these terms typically. Uh, I think my net is a bit slow, but yeah, you can get these terms called as entities, um, and yeah, intent word, entities words, and so on. Intent means what the user actually wants. That is your intent. And there can be multiple intents within a single conversation also. Fine. So now that bot has been able to replied back, okay, from that list, I say that, okay, I'll go for, let's say, uh, veg farmhouse pizza. Okay. Uh, can you order it for me? So what is the natural next question which is supposed to come from the bot? So what order are you, what size are you looking for? Regular, large, extra large, what size? So then I say, okay, I'm going for a regular pizza. Fine. Do you want any specific toppings, crust, this and that? So that is the next natural question. What kind of topping I would need, or what kind of crust? Extra cheese burst, this and that. So all the options will be given to me. Again, in natural language, I'll say, no, I don't want any additional toppings. Whatever is the regular pizza with this particular thing, I would go with that. Fantastic. So the size is defined, pizza is defined. What is the next thing? If these two things are defined, then what is the next thing? Then the bot says, okay, can you give me your details? Okay. Name, phone number, email. Okay. So that I can take your order. Fine. I gave these three things. Fine. The next thing is, how would you like to pay? This pizza with regular size is coming with so and so. The amount with GST, it comes to, let's say, 410 rupees. Just a number, any number it could be. Okay. Now, how would you like to pay? So then I say, okay, I'll pay using my UPI system, which is popular in India anyway. So immediately, since the UPI is there, keyword is there, UPI, fine. Or I'll like to use Paytm or GPay. These are the keywords that bot understands. Immediately a scan barcode would be given. In this, everything is happening there itself. Okay, a barcode would be given, and query fulfillment will happen. Okay, so the order, once it detects that the order has been, sorry, the payment has been done. So see, the problem here is the traditional bots used to only take the orders, and the query fulfillment, that's a technical word, query fulfillment was only up to taking the order and giving it to the system. Okay. The order placement in terms of the payments was not really handled automatically. Now, with these agents, which have access to payment gateways, so you have an agent which can access Stripe or Razorpay, which is very popular in India. Okay, whatever the payment gateways are. Now, let's say if I say I want to go for my card payment. Okay, so then in that case, your agent needs to have access to the payment gateway. Okay, that chatbot, sorry, the chatbot needs to have access to the payment gateway, which was not possible in a traditional chatbot. Now, with these agents coming into picture, okay, we have agents for payment gateways and everything else. Okay, so how we are going to make this more agentic now? Of course, the conversation part and everything will still be handled the way we have. But where did it stop in the case of generative AI? The place where it stopped in the case of generative AI was taking all the order and giving it to the system. Okay. But it never went for the payment, number one. And so the order was not confirmed in the sense, like, since the payment was not done. Okay. Some person would reach out to the customer and say that, sir, you wanted to order so and so pizza. I've got this query from my system. Okay, how would you like to pay? Then that guy would assist me on call for the payment part, or do you want to use cash on delivery or payment on delivery mode? That is also fine. We can deliver it and you can pay the delivery boy. So some human intervention is needed to execute the order at the end. But now with these agents, okay, which can access these payment gateways, okay, the entire payment itself can be automated and the order can be, finalized. Okay, obviously, once the payment has been done, then the bot will say, okay, your payment has been successful. Can you provide me your address where you want it to be delivered? Because till now it has not asked for the address. It has asked only three basic details: name, email, phone number. That's it. And uh, you know, entire thing has been executed. But where is it supposed to get delivered? So why should it know the delivery address even before I have actually placed my order? So now that the payment has been done, so next natural question is, where do you want to get it delivered? So all these things. So yeah, so that's where the entire execution part actually happens. So this is where the thing is. So another example is given out here. So this system uses LLM as its brain, gives access to tools like companies' internal APIs for an order management, shipping, payment processing, and everything. Okay, so payment processing itself may not be handled internally completely. That might need help of another agent which is connecting to your payment gateways. So multiple agents could be coming, okay? And there are multiple tools, like payment processing itself is one tool which is enabled for a different agent. So one agent will call another agent, can you do the payment processing card wise? Another agent who has access to UPI system, okay? Another agent which has access to cash on delivery system. So something like that, okay? I'm just imagining here. So each agent has specific set of tools access. Not every agent will have access to every other tool. That will not only confuse the agent, but also confuse your agentic AI framework. Okay. What all is going where? It will be hard to track and trace. So it's always advisable to create granular atomic agents. In fact, there is a concept called as atomic agents. There is a book also with the same name. Okay, atomic agents, like atomic habits. So there is a concept of atomic agents. So each agent is supposed to perform exactly one task, very specific task, with ideally one or two tools only. If it is supposed to access many tools, then it's better to separate out the agents and orchestrate it as a multi-agent system. Okay. So in this case, end-to-end problem resolution. So customer says my order number 123 has not arrived. Can you help? And then the LLM starts doing the reasoning. Okay. It understands that, okay, I have to first check the order status. Where is it in the pipeline? What step it has reached? And potentially if the refund has been processed or not. And a plan is formulated. So Act. So tool one. So tool one is so basically one of the agent is executing here. So get order status, this API. So this is executed by an agent which has access to your live ordering system. And from here, the response came as lost in transit somewhere, let's say. Then the reasoning starts. So that output, lost in transit, is given back to the LLM. So now the LLM knows, okay, so that package has been lost in transit. So what is the next logical step based on the company policy? So this could be again a RAG-based chatbot or something. Okay, I have to offer customer the choice to get a full refund and so on. So now it responds to the user that it appears that your package was lost in transit. I sincerely apologize, this and that. And we would offer you the full refund or a ship a replacement order if you would like to wait. So what would you prefer? So then the user would say either refund or replacement order. So one of these two would be the keywords in the answer. Okay. So whatever the user says, let's say the user says that I want a refund, then immediately this LLM will start or whatever your agentic framework will start triggering your refund agent. That is another tool basically. Okay, process refund with this so and so order ID. So order ID is automatically passed to another agent which has access to your refund or payment processing system, whatever, and it will execute that refund. Okay, so once the payment uh, processing has happened, it may not immediately reflect, but at least the payment processing has been initiated by the system. Okay, then the confirmation is given back to the user that we have refunded. It should reflect in your account in 3 to 5 business days, whatever it is. So, that is your end-to-end system, which is not only reasoning, planning, but also executing either a replacement order or refund of the lost in transit order. So the outcome here is the AI agent achieves the user's ultimate goal. So that is what I wanted to have when the conversation started. I wanted to have my end query resolved. Let's say uh, I usually go to Uber, okay, use Uber for my local transport cabs, okay, fine, even intercity many a times. So I have seen it many times that the amount initially showed is, let's say, X, on which I have booked it, and especially if the trip is very lengthy, longer, okay, or if the time taken is very long, okay, there are traffic delays, this and that, the final amount which gets deducted is X plus Y. I pay that driver happily, no problem. I know that once I reach home, take my breath, next day I'll start my resolution because payment has already been done. X plus Y. X was the original amount. The good thing is that their system knows what is X and what is X plus Y both. Okay. So I normally go to their support, billing issue, something I don't remember the exact steps, but every time I have gone to that same sequence of steps, okay, automatically my query has been resolved. Okay, I don't know if they are doing it agentic wise or they have a rule based system. Pretty sure it might be a rule based system. So if I say that, okay, I was charged higher than what was initially shown as the fare, then uh, they take time to fetch the X value from their system and they know that X plus Y was paid, so they will refund that Y amount in my wallet or something. Okay. So it's not that the same thing could have not been done, but that was being done by a rule-based system. So if things are more nuanced, you paid additional to the driver. So how do you convey it to your uh, you know customer support? So all these things have to happen via conversations. And for all these, you still need your LLMs and agents to execute all these things.
So today we covered the key differences between AI agent, agentic AI, Gen AI, and traditional AI, and why understanding these terms is crucial for your AI job search. These are the exact skills companies are looking for in roles like AI engineer and Gen AI developer. So don't forget about the free masterclass, which is your ticket to a high-paying AI job. It's a free opportunity where you'll get a proven roadmap and a 3-step framework from experts. So head to the description or pinned comments to register now. And also, if you like this video, be sure to subscribe for more and share it with someone who is preparing for AI interviews. And also, definitely check out this video next.